You are standing on a cold ridge in northern Chile, and the air is so dry it feels like glass in your lungs. Above you, a dome opens, motors hum, and a mirror turns toward a sky that looks black enough to swallow sound. The subject tonight is Vera C. Rubin Observatory, a quiet new watcher with an old name and a camera larger than a car. If this machine does what scientists built it to do, it will change how we spot danger, track change, and measure the dark parts of the universe. Stay close to this channel, and you will keep getting these turning points in plain English, right when the sky becomes a little less mysterious. At first, the pictures look like what people always hope space will look like. Clouds of gas glow in pink and blue. Galaxies crowd together by the millions. Stars punch through the darkness like bits of broken ice. But the strange power of these images is not just beauty. Beauty is the bait. The real story is speed, scale, repetition, and patience. This observatory is not here to take one famous portrait and then rest on it. It is here to watch. It is here to return, again and again, night after night, until motion appears where we once saw stillness. A rock shifts, a star flickers, a whole piece of the sky changes, and for once, we do not miss it. That is why the first release landed so hard. Not because astronomers had never seen nebulae, galaxies, or asteroids before. They have. It landed because, in just over 10 hours of test observing, Rubin had already captured millions of galaxies, millions of Milky Way stars, and thousands of asteroids. And everyone looking at those first images understood the same thing at almost the same moment. This machine is going to make the sky feel alive. To see why this matters, we need to step back. Most people hear the words "new telescope" and think of one simple idea. It sees farther. It takes sharper pictures. It gives us prettier views of deep space than the old machines did. That sounds right, because it matches the way we have been trained to think about big observatories. A giant eye on a mountain, a better lens, a deeper look, a more dramatic photo. And for a long time, that story felt complete. Rubin does sit on a mountain. It stands in Chile, where the dry air and dark skies make the night unusually clear. That part fits the old picture perfectly. A remote place, a giant instrument, a team waiting for first light. Even its hardware sounds like the kind of thing you would expect from a machine built for spectacular images. Rubin's LSST camera has 3,200 megapixels, according to the observatory's own technology page. It weighs about 3,000 kilograms, or 6,600 pounds. It is roughly the size of a small car and about twice as heavy. Its sensors are kept near minus 100 degrees Celsius, so the images stay clean. That alone is enough to make people stop. Most of us are used to cameras that fit in a pocket. This one needs a telescope, a dome, a mountain, and a global data system. Rubin's camera is so large that one image would need hundreds of ultra-high-definition TV screens to display it properly. It sounds less like a camera and more like a building that learned how to see. The observatory's full name matters too. Vera C. Rubin was the astronomer whose work helped reveal one of the deepest problems in modern science. Galaxies were spinning in a way visible matter could not explain. Something unseen seemed to be there. That unseen something is what we call dark matter, a name for missing gravity we still do not fully understand. So right away, the place carries a quiet burden. It is named for a scientist who helped show that the universe is not what it first appears to be. And now this observatory is built to push that lesson further. It was not designed only to admire the sky. It was designed to measure change across it with relentless regularity. That regularity is easy to miss when you first hear the headlines. First images, first look, historic reveal. Those words make it sound like a debut performance, a grand opening night, one bright ribbon cut in public. They make it feel like the main event is the reveal itself. The gallery did not help that first impression. The release page invited people into a cosmic treasure chest. It showed the Trifid and Lagoon nebulae. It showed a swarm of new asteroids. It showed rhythms in the stars. It showed part of the Virgo cluster spread across an enormous field. If you only glanced at those titles, you could be forgiven for thinking the old assumption was correct. Rubin is another giant telescope built to make space look richer and deeper. It will give us grand wallpaper for the mind. It will make posters, covers, classroom screens, and science headlines. That is how many famous observatories enter public life. And there is a reason that assumption is so sticky. Astronomy has trained us to fall in love with single images. One pillar of gas, one spiral galaxy, one deep field with tiny red smudges holding ancient light. A single frame can feel like a whole argument. Rubin seems ready for that kind of fame. One early image, described in search coverage from the Max Planck Society, was built from more than 1,100 overlapping images and reached 3 trillion pixels. Another official snippet from Slack described a Rubin image made from 678 separate images gathered in just over 7 hours. Those numbers sound almost absurd. They push your mind toward magnitude, not method. And then there is the language officials used when the first imagery arrived. Željko Ivazic, director of Rubin Observatory construction, said the release marked the end of about 2 decades of dedication, innovation, and collaboration. Brian Stone at the U.S. National Science Foundation said Rubin will capture more information about the universe than all optical telescopes throughout history combined. Harriet Kung at the U.S. Department of Energy called this a golden age of American science. Those are huge claims wrapped around huge pictures. So the setup feels clear. A famous mountain observatory, a world record camera, a public unveiling, a storm of official praise, a machine built to see more and show more. By the end of that picture, the assumption feels almost locked in place. Rubin matters because it sees farther than we do. Rubin matters because it makes space bigger on a screen. Rubin matters because its images are beautiful beyond anything we had before. That is the neat version, the easy version, the version most people stop at. But that picture is about to change. What we have just taken for granted turns out to be a small part of a much larger story. The beauty is real, but it is not the engine. The size is real, but it is not the deepest surprise. The real shock is that Rubin is less like a portrait artist and more like a timekeeper for the whole sky. Write a comment with the moment your own assumption cracked. That one sentence helps shape what we explain next, because it shows us exactly where the big ideas stop feeling obvious. Rubin's first images did not simply announce a new telescope. They exposed a new way of looking. And once you see that, the whole release starts to read differently. Start with the simplest comparison. What most people expect from a first image is a postcard. You point, you capture, you admire, you move on to the next target. What Rubin actually showed was a system. The official release said that later in 2025, it would begin the legacy survey of space and time and scan the sky nightly for 10 years. Nightly is the key word there, not once, not on special occasions, not only when a team decides something looks interesting. That is the first surprise pattern in this story. The expectation was a better picture. The reality was a better memory. Rubin is being built to remember the sky so faithfully that change cannot hide inside it. That is like checking the same quiet street every night until you finally notice which window has been open all along. Seen that way, the first images become proof of behavior. In just over 10 hours of test observations, the observatory had already caught millions of galaxies, millions of stars, and thousands of asteroids. That was not just a flex, that was a warning shot. It told astronomers that even during a short test, Rubin was already collecting the kind of crowded, changing field that smaller systems struggle to hold together. Then the asteroid story sharpened the point. A telescope made for pretty deep space portraits would treat fast-moving rocks almost like noise. But Rubin's own first-look gallery highlighted a swarm of new asteroids right away. The expectation was distant grandeur. The reality was local motion. It was like lifting a theater curtain and discovering that the floorboards were moving too. That matters for a reason close to home. The solar system is not a neat clock with every part labeled. There are still rocks we have not found. There are still objects that pass in darkness unless someone checks often enough, wide enough, and fast enough. Rubin, according to the Slack release, is expected to find millions of unseen asteroids, comets, and interstellar objects. Now, the observatory's design starts to make sense in a deeper way. Rubin will take about 1,000 images of the southern hemisphere sky every night, according to Slack. That lets it cover the entire visible southern sky every 3 to 4 nights. The expectation was depth alone. The reality is depth plus cadence, a word scientists use for timing. Think less of a single-family photo and more of a decade-long time-lapse of the sky. And that is where the first images stop being static art. A nebula is beautiful. A galaxy field is beautiful. But the bigger promise is that Rubin will come back. It will notice what brightened, what dimmed, what shifted, and what appeared where nothing had been before. In other words, it turns the night sky from a museum wall into a living neighborhood. The stars in the first release hinted at that too. One section of Rubin's first look was called Rhythms in the Stars. Even in the title, the idea is motion over time, not just detail in one frame. The expectation was a still portrait. The reality was a beat. Like hearing a heart through a wall, the meaning comes from repetition. Then there is the field of view, the amount of sky seen at once. Rubin's power is not only that it sees faint things, it sees a lot of them together. That changes the scale of what one night can mean. It is the difference between reading one page with a magnifying glass and opening the entire book on the table. This is why the Virgo cluster image mattered so much to astronomers. It was not just full, it was overwhelmingly full. Search coverage tied to the first release described more than 10 million galaxies in the wider image product. The expectation was a crowded scene. The reality was a census on the edge of feeling impossible. And notice what happens to your sense of size when you hear that. 10 million galaxies is not a better wallpaper. It is a reminder that every patch of sky is busier than our brains naturally assume. In daily life, you glance out a window and count cars, trees, people. Rubin looks out into darkness and finds city after city after city. That same swing between the domestic and the cosmic is part of why these images hit so hard. A child can understand the basic feeling. You thought the room was empty, then someone turned on a stronger light. Only this room is the sky, and the stronger light is paired with a schedule that never gets tired. Officials understood this immediately. Brian Stone's statement for NSF did not focus on one pretty frame. He said Rubin will capture more information about the universe than all optical telescopes throughout history combined. That is not the language of a one-time spectacle. That is the language of a machine that changes the rate of knowing. Harriet Kung's statement carried a similar tone. She did not praise the colors in the first release, she praised the tool. She described Rubin as what becomes possible when scientists and engineers are backed with the tools to lead. Again, the center of gravity is not the image, it is the system that can keep making meaning from repeated images. Michael Kratsios, then leading the White House Office of Science and Technology Policy, called Rubin an investment in the future. That line matters because the future is built into the observatory's logic. A single image is present tense. A survey is future tense. Rubin is not asking only what the sky is. It is asking what the sky does next. Soon after that, another layer of the reveal becomes impossible to ignore. Rubin was built to serve the legacy survey of space and time. Even the name tells you what the old assumption missed. Legacy means the data will last. Survey means the scope is broad. Time means change is not a side note. Time is part of the instrument. Once you hear that, the observatory's camera feels different too. Those 6 filters, labeled U, G, R, I, Z, and Y, are not just fancy options. They help scientists see the universe in different bands of light, from ultraviolet to infrared. The expectation was a giant, ordinary camera. The reality was superhuman color vision. It is like discovering your new pair of glasses can also hear whispers and track footprints. Even the speed of the hardware matters. Rubin's filters can be swapped in less than 2 minutes. That sounds like a dry engineering detail until you remember the mission. A machine built to return to the sky again and again cannot afford to move like a museum piece. It has to work with rhythm. It has to behave less like a ceremonial instrument and more like a practiced crew. Then the data scale rises into view. Slack said Rubin will generate about 20 terabytes of data per night, plus a 15 petabyte catalog database over the survey. Those are numbers so large they stop feeling real. The expectation was a powerful telescope. The reality is a factory for evidence. It is like thinking you bought a good notebook and discovering you have opened a library. About 2/3 of the way into this story, it helps to pause and admit something. Even the people closest to Rubin do not fully agree on which discovery will matter most. Some are watching for asteroids. Some care about exploding stars and other sudden events. Some are thinking about dark matter and dark energy. A machine this broad does not arrive with one neat answer printed on the box. That uncertainty is not weakness. It is one of the strongest signs that the instrument is real. When experts already know exactly what a new machine will give them, the future is usually smaller. Rubin feels different because it is built to catch what does not fit. The surprise may not be where the press release first points your eyes. And that makes the first images more powerful, not less. They are not the conclusion. They are the opening proof that the observatory can move from dream to function. Zeljko Ivazic said construction was complete, and Rubin was now turning fully to the sky. That line lands differently once you understand the mission. The eye has opened, yes, but more important, the watching has begun. So what exactly shocked the scientific world about those first images? It was not that they were lovely, though they were. It was not that the camera was huge, though it is. It was that a short test had already shown the central promise of Rubin's design: wide, deep, fast, repeatable, and impossible to ignore. Astronomy has had great eyes before. Rubin arrives as something closer to a whole nervous system. It does not only stare, it senses changes. It compares nights. It flags movement. It remembers the difference between what was there and what is there now. If the reveal in this story is right, then the way we think about the sky will quietly shift for anyone who ever looks up. And here is where this stops being about one observatory and begins being about us. Because a sky that is watched well is a sky that becomes harder to take for granted, and a universe that changes in public begins to change the people who live beneath it. Send this video to one person who still thinks astronomy is mostly about pretty pictures. That share matters because this story only becomes real when someone else feels the jump from beauty to evidence. Rubin's first images were not the end of a reveal. They were the beginning of a new habit for science. And habits, once they scale, alter the future. So what changes now? First, our sense of urgency changes. A survey that covers the visible southern sky every 3 to 4 nights can catch motion that slower systems miss. That means more notice when something appears, brightens, shifts, or races through our neighborhood. For a family eating dinner under a quiet evening sky, that sounds abstract until one day it is not. Second, our sense of normal changes. We are used to thinking of the night as still. Rubin is built to show that stillness is often just poor sampling. Check often enough, and the universe starts behaving less like a painting and more like weather. Not whether you can control, but whether you can finally track. That matters deeply for asteroid work. The SLAC release called Rubin the most efficient and effective solar system discovery machine ever built. That is a strong line, but the numbers support the ambition. Thousands of asteroids already appeared in just over 10 hours of test observing. Scale that habit across years, and the map of nearby motion becomes far less blind. For the public, the benefit is not only safety, it is honesty. We live better when we know what shares space with us. A child learns that by cleaning under a bed with a flashlight. Civilization learns it by surveying the sky with instruments that return before the dust settles back into place. Third, our sense of cosmic history changes. When Rubin captures millions of galaxies at once, it is not only gathering decoration, it is collecting patterns across enormous distances. Those patterns can help scientists test ideas about dark matter and dark energy, the hidden ingredients tied to Vera Rubin's own scientific legacy. A prettier image fades. A stronger map keeps arguing with theory for years. Here the dates start to matter more. The LSST camera was installed on the Simone Survey Telescope in March 2025, according to Rubin Observatory. The first imagery was released on June 23, 2025. Later in 2025, the observatory said the 10-year legacy survey of space and time would begin. Those are not just calendar marks. They are the first beats of a decade-long clock. And the numbers tighten with them. About 1,000 images each night. The visible southern sky covered every 3 to 4 nights, roughly 20 terabytes of data per night, a catalog growing toward 15 petabytes. As the schedule sharpens, the future stops sounding poetic and starts sounding operational. That precision changes how discovery itself feels. Instead of waiting for a rare, lucky look, scientists can begin asking whether an event happened between Tuesday and Friday. Instead of wondering if a flicker was real, they can compare passes. Instead of building stories from thin samples, they can build them from repeated return. In science, that kind of regularity is often where trust begins. There will still be mysteries. Some events Rubin catches will be easy to name, some will not. A light may brighten and fade in a way no one predicted. A moving object may behave oddly before anyone agrees what it is. The observatory's strength is not that it ends uncertainty. It is that it gives uncertainty nowhere comfortable to hide. For people at home, there is a quiet domestic anchor in all this. Think about the way your phone organizes photos by date. A single picture tells you what a face looked like once. A long sequence tells you how a child grew, how a room changed, how time actually moved through your life. Rubin is giving astronomy that same memory, only on a scale so large it almost hurts to imagine. And once memory improves, responsibility grows with it. A better record means fewer excuses. If something important flashes in the sky, Rubin has a chance to catch it. If a near-Earth object moves through the dark, Rubin has a chance to notice it. If a star changes rhythm, Rubin has a chance to log the beat. The future of astronomy becomes less about hoping and more about staying ready. There is also a human change that is harder to measure. People who grow up with Rubin may think of the sky differently from the start, not as a fixed ceiling, not as a static backdrop behind their lives, but as a place of ongoing updates, new notices, new motions, new returns. That is a cultural shift as much as a scientific one. The official language around the first imagery hinted at that scale of change. NSF called the images a preview of a mission to explore some of the universe's biggest mysteries. Slack described Rubin as a facility that will drive discovery. Those are broad promises, yes, but the hardware, the cadence, and the early results give those promises weight. So when people say the first images shocked the scientific world, the best version of that sentence is not about surprise alone. It is about recognition. Astronomers saw the release and recognized a threshold. A machine built over decades had finally shown that it could do the strange, hard thing it was meant to do. It could watch the sky in a way that changes the meaning of seeing. What comes next will be quieter than the reveal and more important. Tomorrow, and the night after, and the night after that, the power of Rubin will live in repetition. Not in one stunning press image, in the return, in the check, in the difference between one pass and the next. Soon, someone somewhere will open a fresh data stream from this observatory and notice a change no human eye ever could have tracked alone. It may be a faint moving rock. It may be a star behaving badly. It may be a pattern spread across galaxies too numerous for any person to count by hand. Whatever it is, it will arrive because a machine kept showing up. That is the horizon Rubin opens. A future where the sky is not sampled in rare dramatic bites, but watched with discipline. A future where the unknown is still vast, but less able to pass by unnoticed. A future where the dark is still dark, but it leaves more footprints than it used to. For science, that is a profound shift. So save this video and come back after the next Rubin milestone. That private habit will help you feel the story as it unfolds, not as a memory after everyone else has already told it for you. Because the single image worth carrying away is not only a nebula or a galaxy field, it is a date, June 23rd, 2025, and a machine beginning to keep watch. Picture that cold Chilean night once more. A dome opens. A camera the size of a small car waits at -100 degrees Celsius. Somewhere inside a flood of incoming light, the next clue is already on its way. And I think the future will belong, in part, to the instruments patient enough to notice it.